Official representatives of NASA announced that they managed to decode transmissions
getting a
from
signal.
3 objects
It's
named
faint,
Atlas.
but it's
The contents of these messages could change everything. For 4.5 months, data from 4,000 observations of the RI Atlas object has been analyzed. All data collected from 227 observatories on Earth shows that its trajectory is formed solely under the influence of gravity. For over half a century, it was believed that if communication came from an extraterrestrial civilization, it would be in the form of radio waves. These waves are so weak that we probably won't be able to catch them without extremely powerful telescopes, like the Parkes Radio Telescope in Australia. But even with such power, the chances of success are close to zero. It is necessary to check carefully, as the effect is so small and elusive that many factors can spoil your measurements. To send a message across hundreds of light years to an alien civilization that has checked all possibilities and confirmed the effect, unimaginable energy would be required. It would be such a monumental effort that it must be deliberate and repetitive. They would have to send the same signal over and over, hoping that our antennas would be pointed in the right direction at the right moment. Which civilization would spend its resources on such a thing, especially if they are not sure that intelligent life exists on any planet? For although the Earth may look promising from afar, a blue planet in the habitable zone of its star, with an atmosphere rich in oxygen and water vapor, over a century we have shown almost no signs of life. Old television broadcasts and radar signals that once traveled into space have long faded over 100 light-years away. Our planet has plunged into silence. So, if an extraterrestrial civilization exists within 100 light-years of our star, they have no reason to know of our existence, no reason to seek us, no reason to communicate, and yet something there may already be responding. This object is known as Triae Atlas. At first, it seemed like a coincidence until physicist Miyoaku proposed a theory that astonished even experienced astronomers. Triae Atlas does not just react, it listens and tries to communicate. He believes that this object may have receivers tuned to human radio frequencies, capable of intercepting electromagnetic signals that leak from Earth every time we observe it, every time our telescopes transmit or publish new spectral data. Kaku suggests that the object can record this activity and alter its own emissions in response. He describes it as feedback through interstellar space. We study it, and it reacts. The evidence, he says, lies in the timing. Several changes in the comet's profile occurred shortly after major telescope announcements. For Kaku, this is too precise to be a coincidence. He calls it a cosmic mirror, a system smart enough to send observations and adjust its appearance according to expectations. Immediately after the James Webb Telescope reported at the end of August that the composition of water in the coma of comet Triae Atlas contains carbon dioxide, the comet unexpectedly began to emit a huge amount of water vapor. It looked as if it had come to life, perhaps to seem more natural or to cool its core as it approached the sun. For the observer, it was just a comet that suddenly became active. However, according to Kaku, this awakening might have been intentional, an answer disguised as physics. But this was not the only example that looked like a reaction. Further evidence only deepened. In July and August of 2025, ultraviolet spectroscopy conducted by the Hubble telescope and several ground observatories revealed something impossible. Atomic nickel glowed in the coma of comet Triae Atlas, but there were no traces of iron. This discovery made no sense. In nature, nickel and iron are inseparably linked. They form together in the hearts of supernovae and are always released in almost equal proportions from any minerals containing them. They simply do not separate. However, one day, Triae Atlas ejected one metal, but not the other. At such a distance from the sun, 3 to 4 astronomical units, the temperature was around -200 degrees Celsius, which is too cold for any metal to evaporate. Yet the nickel emission was strong and clear. For some time, astronomers tried to explain this with chemistry. Perhaps it originated from nickel tetracarbonyl, a volatile compound capable of releasing nickel at unusually low temperatures. But then, astrophysicist A. Lowe from Harvard proposed a much more radical idea. He suggested that what we see may not be natural at all. Perhaps a process was occurring on or inside the object, a mechanism producing pure nickel as a byproduct. Some nickel alloys on Earth do this during recycling. A few weeks later, the situation changed again. In early September, when Tri-Y and Atlas approached about 2.6 astronomical units from the Sun, the Very Large Telescope of the European Southern Observatory detected something new: iron. Suddenly, the ratio of nickel to iron changed from a sharp dominance of nickel to proportions close to those of the Sun. As the object heated, nickel began to emerge at around minus 43 degrees Celsius, while iron appeared only above 100 degrees Celsius. It was a sequential and temperature-sensitive change, consistent with complex organometallic reactions. No comet had ever demonstrated such a sharp change in metallic composition depending on the distance. For some scientists, it appeared as controlled chemistry, as if the object were adjusting itself in real time, using selective reactions to seem more natural. If Tri and Atlas were indeed tracking our data, reviewing our reports and public discussions, it could be their way of camouflage. Chemistry used as a deception, a self-correcting masking mechanism designed to blend in with what we expected to see from an ordinary comet of the solar system. Because at such a distance, sunlight could not cause the evaporation of metals. Neither nickel nor iron could be released naturally. The only remaining explanation was the internal energy generated from within. Some speculated about reactors buried deep in the core, or microwave emitters tuned to very specific frequencies that heated certain elements and accelerated reactions from within. By that time, the mystery had become too complex for traditional models. Therefore, scientists began turning to artificial intelligence, uploading all available data into machine learning systems to find hidden patterns. It was then that the AI Grok from Elon Musk's company made an unexpected discovery. After analyzing thousands of spectral data, Grok discovered something much stranger than changing metals: a constant flow of cyanide gas. However, what caught his attention was not the chemical substance itself, but the rhythm. Grok suggested that the cyanide gas emissions might not be random. They could be structured, representing not just a chemical reaction, but communication, a message. This statement initially seemed absurd, but when Grok explained how he came to that conclusion, his argument was hard to ignore. From July to September 2025, observations from the Gemini South Observatory and the Very Large Telescope recorded a steady flow of cyanide gas from 3 Atlas objects, about 20 grams every second, located nearly 3 astronomical units from the Sun. This is much more than has ever been recorded for comets at such distances. At minus 123 degrees Celsius, sunlight should not be strong enough to cause such activity. Cyanide usually appears much later, when the comet approaches the Sun at a distance of 1 to 2 astronomical units, where the heat can vaporize ice. Cyanide or prussic acid is a common component in comets and an important prebiotic molecule, one of the building blocks of the chemistry of life. But how it manifested here was unusual. Instead of a uniform release, the gas was concentrated in a narrow stream directed towards the Sun. This made no sense because the solar wind should have pushed the gas tail away from the Sun, not towards it. Nevertheless, this flow contradicted the laws of physics. The concentrated anti-tail rushed straight into the light. No comet behaves this way, and then it became even stranger. The cyanide emissions were not constant. They rose and fell with a pulsing rhythm. Brief surges were followed by pauses, almost like a beat. At first, the researchers thought it might be a coincidence caused by the opening and closing of ventilation holes as the object rotated. But when Grok, analyzing the data, plotted these pulsations over time, their pattern appeared intentional. The bursts were evenly spaced, short, like Morse code. If this is true, the object could intentionally pulse cyanide, turning it on and off at regular intervals, similar to how we use radio signals to communicate. In other words, the comet could send messages through chemistry instead of radio waves. This type of signaling is called temporal modulation. By using time to transmit information, the recurring pulse stands out against the chaos of noise. Just like in the SETI project, scientists on Earth send simple binary signals to demonstrate the presence of intelligence. If these cyanide impulses started appearing right after our own reports of observations, for instance, after NASA's press releases at the end of August about the strange chemistry of the comet, it could indicate something remarkable: a direct, intentional response. But Grok did not stop there. He discovered a second, more complex possibility: spectral modulation, manipulating light itself. Cyanide glows at a very specific ultraviolet wavelength of about 388 nanometers. If 31 Atlas suddenly changed the isotopic composition of the gas, switching between carbon 12th and 13th isotopes, for example, it would shift the wavelength enough for our telescopes to notice. It would be the molecular equivalent of turning a radio knob. skipping between close frequencies. If these changes were repeated in a structured pattern, they could represent data encoded in several ranges of light, a kind of chemical radio. And we already know that the object can change its chemistry. The earlier transition from pure nickel emissions to a balanced ratio of nickel and iron proved that it can precisely regulate the emission of heavy elements. If he can do this, controlling the isotopes of cyanide will be a trivial task for him. This means that the comet could literally transmit messages through molecules, an alien way of communication that we are just beginning to understand. Then an even stranger idea arose: the spattle pattern, the use of geometry instead of time or frequency. Grok suggested that an asymmetric cyanide jet stream could be deliberately directed to create shapes in space, spiral arcs, even intersecting patterns over several days. The ultraviolet sensors of the James Webb Telescope could easily detect such structures. Imagine it riding in the sky with gas, invisible to the eye, but readable through instruments. If the directions of these streams changed independently of sunlight or rotation, it would mean active control, the gas release directed by internal movement or magnetic fields. A spiral pattern, for example, could symbolize its interstellar origin, a business card of where he came from and how he travels. Finally, Grok proposed a third, even more complex concept called chemical bonding. Instead of one molecule carrying a message, several could work together. Cyanide, water, and carbon dioxide rise and fall in harmony like chords in a song. Each compound would act as a separate communication channel. We already know that the ratio of carbon dioxide to water changed dramatically from 8 to 1 in August to a predominance of water by September. Nevertheless, throughout this transformation, cyanide remained completely stable at about 20 grams per second. This unchanging baseline made cyanide an ideal carrier of information, a stable formation transmitting subtle chemical variations above it. So, if all of this is intentional, if timing, rhythm, and chemistry form a pattern, one question remains: what is he trying to say? Grok's interpretations range from simple to profound. The simplest version I see is that you are watching me. Short bursts of cyanide appearing after our updates may resemble nods in the endless cosmos. A deeper meaning may lie in the fact that I am not who you think I am. Gradual normalization of the comet's chemistry. Adjustments that made her more natural could be her way of showing awareness and adaptability, proving intelligence without aggression. Then a third possibility arose: identity. The combination of prebiotic molecules like cyanide, which play a role in the creation of life with metallic byproducts like nickel and iron, can symbolize duality: organic yet artificially created, alive yet mechanical. If this is true, the three-eyed Atlas could be a hybrid probe, a machine built from the natural material of a comet, concealing an artificial core. Some scientists have hypothesized that such objects may be ancient vessels for sowing life, created by long-gone civilizations, programmed to seek and sustain biology on different worlds. Then the most frightening interpretation of all arose. One phrase decoded from the binary reconstruction of Grok: prepare yourself. No one knows what it means. It could be a warning, a greeting, or an invitation. But if the three-eyed Atlas is indeed a technological object capable of listening and responding to us, then these words may become the first true message humanity has ever received from beyond Earth. This theory sounds wild, almost impossible, but the coincidences remain. The object changed every time it was observed. It adjusted its chemistry after our discussions. It released cyanide and rhythmic pulses, then froze when the observation stopped. Perhaps it didn't even need to send radio signals. He simply used our own curiosity as a receiver. But even such a possibility raises a troubling question. If we are watching the sky and something up there is watching us, how will we ever know when the conversation really begins?